This section is 7.5, using proportional relationships. The first example says, a student wanted to find the height of a statue of a pineapple in Nabor, Australia. She measured the pineapple shadow and her own shadow. The student's height is 5 feet 4 inches. What is the height of the pineapple? So if we look down here at the figure, it says that the base of the shadow is 2 feet. Her height, the problem tells us that her height is 5 feet 4 inches. And then if we look at the pineapple on your paper, it's 8 feet 9 inches. I can't really see because it's a little bit blurry. So the first thing we have to do is convert all these different heights to inches. So her height right here is AC, which is equal to 5 feet 4 inches. And so we know when converting feet to inches, for every foot it's worth 12 inches. So we will basically multiply 5 times 12, which is 60, plus the 4 inches, and so this converts to 64 inches. And then right here on BC, it's 2 feet. So we basically take that 2, multiply it times 12, and so this one converts to 24 inches. And then on the pineapple, I can't really see that. I believe it's EF. The pineapple is 8 feet and 9 inches. And so when we multiply that, we have 8 times 12 plus the 9 inches. We know 8 times 12 is 96. Plus the 9 inches is going to be 105 inches. And so that's the conversion of converting all of those to inches. And so then the question asks us, she measured the pineapple shadow and her own shadow. The height, the student's height is 5 feet 4 inches. What is the height of the pineapple? Well, since these triangles are similar because the shadow is parallel, they would basically consider up a proportion. So my proportion, I'm gonna do height to the base. So if we do height versus the base, then the height, we converted that to 64 inches over the base, which was converted to 24 inches. And for proportions, we know that it's equivalent to the height of the pineapple, which is our unknown, over the base of the pineapple, which was converted to 105 inches. And then we'll solve by cross multiplying. So we multiply 64 times 105, which I need my calculator. And so 64 times 105 is going to give us 6,720, and 24 times x is 24x. Divide by 24 on both sides, and so we get 6720 divided by 24. The pineapple's height is 280 inches. And so there is our answer. Any questions? I'm sure you have questions, but you can't ask them. All right, moving along. Scale drawing versus the scale. The definition of a scale drawing, I'm not going to write it. You can write it. A scale drawing represents an object as smaller than or larger than its actual size. Represents an object that's smaller than or larger than its actual size. I'm sure if you remember back in 6th grade math when y'all took the little Model T cars, like the little Hot Wheel cars, and on the bottom of it, it had what this model represented and what the actual real car that's sitting in the parking lot represents. So that's kind of a scale, showing the different scales. Of course, it's not a scale drawing, but that was an actual model. But it represents the actual size, so smaller than the actual larger size. A scale is the ratio of any length in the drawing to the corresponding actual length. Most of the time we'll be able to see these on maps You know, a map is just a smaller version of the actual big city. And so in the bottom it'll tell you the actual scale. And so it's just the ratio of any length in the drawing corresponding to what the actual big ratio is. And so down here we're going to look at an example of a scale drawing. It says the scale of this map right here, which you can see on your paper, of downtown Dallas is 1.5 centimeters for every 300 meters. Find the actual distance between Union Station, which is right here, and the Dallas Public Library, which is up there. And so since it tells us that every 1.5 centimeters represents 300 meters, then when we look here on the distance, what you'll actually have to do is take a ruler and measure it on the map. And when you measure it, the distance is going to be 6 centimeters. And so for every 1.5 centimeter, we know it represents 3 meters. So then we know on our map it's 6 centimeters, so we're going to convert it to meters. So we're going to cross multiply, and I can do that in my head. 3 times 6 is 18. Add 2 zeros is 1800. Cross multiply here, we have 1.5x. And so then we divide 1800 divided by 1.5. And so the distance is 1200 meters in real life. And so this is an example of a scale. Let's look at the next example. And I'm going to read from my book because it's a little blurry up here and I really can't focus. So this one's actually the Lincoln Memorial, which is located in Washington, D.C. And it's approximately 57 meters long in real life and 36 meters wide. Make a scale drawing. So we're going backwards and making a scale drawing of the base of the building. Using the scale, every 1 centimeter represents 15 meters. So, gotta pause. Okay, so since we're finding 2 different ones, for every 1 centimeter it represents 15 meters. So first let's find the width. We don't know how many centimeters it is because we're making a scale drawing, but in real life we know it's 36 meters. So cross multiply, we get 36 equals 15. X divide by 15 on both sides, sorry. And so on the scale drawing it will be 2.4 centimeters. Then we have to do a conversion for the length. So we have for every 1 centimeter, we know it represents 15 meters. We don't know how many centimeters it is, but in real life we know it's 57 meters. So cross multiply, we get 15x equals 57, divide by 15. And so 57 divided by 15 is 3.8 centimeters. And so if we were to actually do a scale drawing, kind of what you're going to do on your project when you make a scale drawing of your dream house, then basically we have our actual size, and if we were to do like a little mapping of it, the drawing would be 2.4 centimeters versus 3.8 centimeters. Got it? Hope you do. If not, pause and rewind. Rewind. Okay, here we're talking about similar triangles. We have a similarity. Oh, let me double check this still recording. Okay, I didn't want to be talking and then have to do it all over again. All right, so with the similarity ratio, you see we have a triangle, 2 triangles here. And so to find the similarity ratio, of course, you know, you would have to do something like the base over the small one over the base of the bigger one, or you could do the side lengths or the hypotenuse. Once you figure out the similarity ratio, which in this triangle is 1/2, and you can see it on the note sheet. Whenever you're trying to find the perimeter ratio or the area ratio, basically what you're doing is taking the perimeter of this figure, like if we were to add that up, 5 plus 4 plus 3. The smaller one has a perimeter of 12. The larger one has a perimeter of 24. And so 12 over 24 is the similarity ratio. It basically is the same as the perimeter ratio. Now area, we know with area, it's always squared, like centimeter squared. The dimensions are squared. So you would have to take whatever your similarity ratio is and square it to find the area. And so that kind of brings us to our proportional perimeter and area theorem. It says that the similarity ratio of two figures is A over B. Then the perimeter of the ratios is the same, A over B. And to find the area, you square A squared over B squared. So let's look at an actual example. So down here it says given triangle RST is similar to triangle UVW. That little tilde means similar. Find the perimeter and the area of triangle UVW. Well, when we look at it first, we see the perimeter and area of the smaller triangle, and we see the base of this one is 16, the base of this one is 20. And so first step will be to find the similarity ratio. So I like to, since we're doing this triangle versus this triangle, the similarity ratio is going to be 16 over 20. And then we would have to reduce that, so this is the similarity ratio. And we know both of them are divisible by 4, so this gives us 4 over 5. That is our similarity ratio. So what we know is that the perimeter, remember the similarity ratio and the perimeter, it stays the same. So if we're trying to find the perimeter of UV, we know that the similarity ratio is 4 over 5, and the perimeter of this triangle is 36. And so when they're proportional, we can find the perimeter of, and I don't want to use X, I'll use P since we're talking about perimeter. And so now, since we know that they're proportional, the similarity ratio and the perimeter, say they equal to each other and cross multiply. So if 36 times 5, which is 180, equals 4P, divide by 4, and so the perimeter of UV is going to be 45. Everybody got that? I'm going to come back to this side, and now I'm going to do the area. So remember with the area, we have to take whatever our similarity ratio is and do what to it? You're right, you got to square it, because it's area. Side times side, length times length, width. Yeah. So 4 squared is 16. 5 squared is 25. Hold on, somebody's knocking on my window. We're almost done. And so then we set it equal to the area, which is here, of the smaller one, which is 40, and I cannot see 8. Cross multiply. 25 times 48 is 1200 equals 16x. Divide by 16. And so the final answer for the area is going to be 75. And that is how you use the similarity ratio to find the area and the perimeter. Thank ya. Rewind if you don't understand and go back and look at your notes.